What is the atmosphere? Explain its composition and describe the importance of the major gases present in it. The atmosphere is a blanket of air surrounding the earth that is pulled down and held in place by gravity. It is a mixture of gases in various proportions that are vital for the survival of all living beings. The atmosphere regulates Earth's temperature by trapping the sun's energy, prevents it from escaping into space, and shields us from harmful solar radiation. Composition of the atmosphere. The atmosphere consists of gases, water vapor, and tiny dust particles. Its gaseous composition is divided as follows: nitrogen 78%, oxygen 21%, argon 0.93%, carbon dioxide 0.04%, other gases 0.03%. Water vapor in the atmosphere varies with altitude and typically ranges between 0.1% and 0.4%. Importance of the major gases and components. Nitrogen and oxygen. These are the two primary and most abundant gases in the atmosphere. Both are essential to supporting life on Earth, and oxygen specially makes up the air we breathe, and oxygen specifically makes up the air we breathe. Ozone. Present in the atmosphere. Ozone gas shields life on Earth by filtering out the sun's harmful radiation, including ultraviolet UV rays. Carbon dioxide. It acts as a greenhouse gas that traps heat in the atmosphere, helping to regulate global temperatures. Water vapor. It plays a significant role in cloud formation and precipitation. Describe the different layers of the atmosphere. Explain the main characteristics and importance of the troposphere, stratosphere, mesosphere, thermosphere, and exosphere. The atmosphere is structured into 5 distinct layers, which are defined by changes in temperature and air density as altitude increases. Troposphere. This is the lowest and most critical layer of the atmosphere, extending from the Earth's surface to an average height of about 12 kilometers. Within this layer, temperature steadily decreases as altitude increases. It contains the air we breathe, along with the vast majority of the atmosphere's water vapor and clouds. Importance. Nearly all weather phenomena, including rainfall, fog, and hail, occur within the troposphere. It is separated from the stratosphere by a transition zone called the tropopause. Stratosphere. Located directly above the troposphere, this layer extends up to 50 kilometers. It is highly stable and characterized by being entirely free of clouds and other weather disturbances. Importance. Its stable, cloudless conditions make it ideal for flying aeroplanes. Most importantly, it contains the ozone layer, which shields life on Earth by filtering out the sun's harmful ultraviolet radiations, UV radiations. The stratosphere makes its upper boundary within the mesosphere. The stratopause makes its upper boundary with the mesosphere. Mesosphere. This is the layer of the atmosphere extending from the stratopause up to a height of 80 kilometers. Like the tropopause, temperature in this layer decreases as altitude increases. Importance: it serves as a vital shield for Earth, as most meteorites entering from space burn up in the mesosphere before reaching the ground. Its upper limit is marked by the mesopause. Thermosphere: extending from 80 to 700 kilometers, this layer contains the ionosphere. Temperatures here rise very rapidly with altitude because gas molecules absorb solar X-ray and short-wave ultraviolet radiation. Importance: the thermosphere is essential for global communication because it reflects radio waves transmitted from the Earth back to the surface. It is also where the spectacular northern and southern lights, auroras, occur, as solar winds interact with different atmospheric gases. Exosphere: the uppermost layer of the atmosphere, which is characterized by extremely thin air. Gravity is so weak in this layer that light gases like helium and hydrogen easily float from here into outer space. Importance: like all the layers below it, the exosphere plays a vital role in Earth's broader atmospheric process, affecting weather and climate systems. What is the difference between weather and climate? Explain the major elements that influence weather and climate. The primary difference between weather and climate is the time frame and geographical scale. Weather refers to the hour-to-hour and day-to-day conditions of the atmosphere in a particular place. It is highly temporary and can fluctuate rapidly, sometimes even within a single day. Climate represents the cumulative average of weather conditions and variations over a large area across a much longer period, typically 30 years or more. Major elements influencing weather and climate. 5 major atmospheric elements constantly interact to shape both daily weather and long-term climate. Temperature. This measures how hot or cold the air is, varying between day and night as well as across seasons. It is primarily distributed by insolation, the solar energy intercepted by the Earth, which is strongest at the equator and steadily decreases towards the poles. Atmospheric pressure. This is the weight of the air pressing down on the Earth's surface. It decreases rapidly as altitude increases. Temperature changes drives horizontal pressure differences. Warm air rises to create wet, cloudy, low pressure zones, while cold air sinks to create clear, sunny, high pressure zones. Wind. Air naturally moves from areas of high pressure to areas of low pressure, creating wind. Wind can range from gentle breezes to destructive storms. It includes local winds like sea breezes, land breezes, which help moderate coastal temperatures. Humidity. When water evaporates from land and water bodies, it becomes water vapor. Humidity is the measure of this water vapor present in the air. Because warm air has a higher capacity to hold moisture, warmer days often experience higher humidity, making conditions feel damp and sticky. Precipitation. When the atmosphere becomes saturated with water vapor, the moisture condenses and falls back to Earth due to gravity. It can fall as rain, drizzle, snow, sleet or hail, with liquid rain being the most common form. Explain atmospheric pressure and wind. How are high pressure and low pressure areas formed and how does air move between them? Atmospheric pressure and wind. Atmospheric pressure. This is the pressure exerted by the weight of air on the Earth's surface. Atmospheric pressure is highest at sea level and decreases rapidly as altitude increases. Wind. The movement of air from a high pressure area to a low pressure area is called wind. Wind can range from a gentle breeze to strong storm. How high pressure and low pressure areas form? The horizontal distribution of air pressure is primarily influenced by the temperature of the air at any given place. Low pressure areas form in regions with high temperatures. The warm air heats up, expands and rises. This rising air creates a low pressure zone at the surface, which is typically associated with cloudy skies and wet weather. High pressure areas form in regions with lower temperatures. The cold air is dense and heavy, causing it to sink toward the Earth's surface. This sinking air creates a high pressure zone which is typically associated with clear and sunny skies. How air moves between them. Air always moves horizontally from high pressure areas to low pressure areas. This movement is driven by nature's attempt to balance the pressure differences in the atmosphere, creating what we experience as wind. What are land breeze and sea breeze? Explain how they are formed and distinguish between them. Land and sea breezes are local winds that occur in coastal areas. They are driven by the differential heating and cooling of land and water, and they are essential in maintaining moderate climatic conditions along the coast. How they are formed. Sea breeze, daytime. During the day, especially in the afternoon, the land heats up much faster than the water and becomes relatively warmer. The warm air over the land expands and rises, creating a low pressure region over the land. Because air naturally moves from high pressure to low pressure areas, cooler air begins blowing from the high pressure zone over the sea towards the land, forming a sea breeze. Land breeze, night time. At night, the process reverses due to differential surface cooling. The land cools down much faster than the sea. Consequently, the air over the warmer water is warmer and rises, while the cooler, heavier air over the land creates a high pressure zone. This causes a local wind to blow from the cooler land towards the warmer sea, forming a land breeze. Differences between land breeze and sea breeze. Sea breeze feature: direction, blows from sea to land. Time of the day, occurs during the day, especially in the afternoon. Temperature cause, land becomes warmer than the sea. Surface pressure, low pressure forms over the land. Wind speed, generally stronger due to larger daytime temperature differences. Land breeze, direction, blows from land to sea. Time of the day, occurs during the night. Temperature cause, land cools faster than the sea, making the water warmer. Surface pressure, low pressure forms over the sea. Wind speed is low because the nighttime temperature and pressure difference is small. Describe the four main seasons of India as recognized by the Indian Meteorological Department IMD. Also mention the traditional 6 seasons of India. The four main seasons. The Indian Meteorological Department recognizes four distinct seasons across India. Winter lasts from December to early April. The coldest months are December and January, where average temperature sits around 10 to 15 degrees Celsius in the northwest and increases up to 20 to 25 degrees Celsius in the mainland India southeast. Summer or pre-monsoon spans from April to June or up to July in northwestern India. The average temperature across most of inland India ranges between 32 to 40 degrees Celsius. April is the hottest month in western and southern regions, while May is the hottest in northern regions. Monsoon or rainy. Advancing monsoon spans from June to September. This season is dominated by the humid southwest summer monsoon, which sweeps across the country starting in late May or early June. Rain begins to recede from northern India in early October, while southern India typically receives more rainfall during this period. Post-monsoon, retreating monsoon lasts from October to December. In northwestern India, October and November are usually cloudless. Note: the temperate Himalayan states also experience two additional seasons, autumn and spring. The traditional 6 seasons of India. Traditionally, India recognizes 6 seasons, each lasting approximately 2 months. These seasons are based on the astronomical division of the 12 months of the year into 6 distinct parts. Vasant, spring; Grishma, summer; spring, summer; monsoon, early autumn; late autumn; winter. Note: these traditional seasons and their exact duration may vary across different parts of the country. What is monsoon? Explain the mechanism of the southwest and northeast monsoons, including the changes in pressure and direction of winds. What is a monsoon? A monsoon refers to the seasonal reversal in wind direction over the course of a year. The word originates from the Arabic term mausim, which literally means season. In India, these seasonal winds are divided into two primary systems, the southwest monsoon and the northeast monsoon. Mechanism of the monsoons. The mechanism of both monsoons is driven by the unequal heating and cooling of land and sea, which creates contrasting pressure zones. Because winds always move from high pressure area to low pressure area, these temperature contrasts drive the seasonal reversal of winds. The southwest monsoon, summer monsoon, June to September. Pressure changes. During the summer, the Indian landmass heats up much faster than the surrounding ocean. This intense heating creates a low pressure area over the Indian subcontinent, while the cooler Indian Ocean maintains a high pressure area. Wind direction. Due to this pressure difference, moist wind blows from sea to land, from the high pressure ocean to low pressure land, across the Indian Ocean, the Arabian Sea, and the Bay of Bengal. Impact. These humid winds bring heavy, widespread rainfall, accounting for most of India's annual precipitation. The northeast monsoon, winter monsoon, October to February. Pressure changes. In winter, the process reverses as the Indian landmass cools down much faster than the surrounding oceans. This creates a high pressure area over the cold land and low pressure area over the warmer seas. Wind direction. Wind reverses direction and blow from land to sea. from the high pressure land to the low pressure ocean. Impact. Because they originate over land, these winds are cold and dry, bringing into little to no rain to most part of India. However, as they cross Bay of Bengal, they pick up moisture and bring crucial winter rainfall to the southeastern coast, primarily Tamil Nadu, Andhra Pradesh and parts of Karnataka.